Conference will now be recorded.
So guys, and finally, okay, according to the last three classes, okay, on Monday, Tuesday, and sorry, according to last two sessions, okay, big data analytics is a process of big data analytics is a process of collecting the data, processing the data, and analyzing the data. See guys, collecting the data, validating the data, processing the data, and analyzing the data. So guys, if you observe the big data analytics definition, if you study the definition of big data analytics, you can find out three different disciplines. And the first one is data engineering is one discipline, and machine learning engineering is another discipline, and business intelligence engineering, BI engineering, is another discipline. Of course, BI engineering means data visualization part. Okay. So guys, when it comes to here, guys, so one of the discipline, guys, we are discussing is data engineering. See guys, data engineering is a crucial discipline of, okay, data analytics, crucial discipline of data analytics. And okay, and that focus on collect, process, store, analyze data. Maybe better you can write that focus on, better you can say design. You can also write design comma construct, design comma construct, and maintenance of okay system for collection, for uh, collection and comma, okay, store and analyze data, okay, collection comma process, store and analyze data. So guys, finally you're building a, okay, you're building data engineering pipelines. Guys, you build data engineering pipelines, and that's the reason build, design, and build and maintenance of the system for collection, process, store, and analyze data. That means, guys, you build pipelines. Those pipelines are responsible for collecting the data and processing the data and storing the data. After that, finally, you analyze the data. For analyzing the data, either you can use for machine learning as a predictive analytics and data visualization as a descriptive analytics. So, and tell me, sir, if I want to build data engineering pipelines, if you want to build a data engineering pipeline, what are the services and what are the tools required from Microsoft Azure Cloud Computing Platform? Okay, so here, let me write, okay, one point. See, guys, Azure Data Engineering. Sir, Azure Data Engineering is a, okay, specialized domain, is a specialized domain uh, in Microsoft, in Microsoft Azure Cloud Computing, Azure Cloud Platform. Okay. So what are the different services required here? And so especially, guys, you tell me that according to the definitions which we discussed yesterday, okay, like distributed computing platform. Sir, if you want to process big data, if you want to process very large volumes of data more efficiently, if you want to process large volumes of data more efficiently, on a distributed computing platform. Okay, we are going to use one of the major service, guys, and is Azure Databricks. Sir, Azure Databricks. Sir, this Azure Databricks is a service, from Microsoft Azure Cloud Computing Platform, and this service supports distributed computing. Computing means what, sir? Processing. Distributed computing means distributes the data and process the data across the multiple nodes or multiple machines. And guys, this service is built on top of, guys, this is the service. Azure Databricks is a service which is built on top of Apache Spark. Now I'll explain you what is Apache Spark. I'll explain, guys, what is an Apache Spark. And soon, within 5-10 minutes, we'll come to the Apache Spark. So this is the major service. This is one of the very important service that supports a distributed computing, okay, approach. Yes, it's a distributed computing framework to process a huge volumes of data. Yes, and the other one, especially for data ingestion purpose, we are going to use, okay, and Azure Data Factory. Azure Data Factory is the one service. And for storing the data, for data storage purpose, we are going to use Azure Data Lake. Azure Data Lake Storage, okay, Gen 2. Azure Data Lake Storage Gen 2. Azure Databricks, Azure Data Factory, Azure Data Lake Storage Gen 2. Okay, so guys, these are the some major services we are going to use. Apart from that, as we can use, depends on the need and project requirements, we are going to use Azure Key Vault and the Azure Logic Apps. And other things like, okay, Azure Synapse, okay, uh, dedicated, okay, SQL pool, okay, maybe, and some other, okay, services like, okay, um, it depends on the need, guys. These are the, okay, services, okay, Azure Blob Storage and the Azure SQL database. It's like a cloud-based relational database. Cloud-based relational database. Okay, so guys, there's a plenty of the services, depends on the project requirement you are going to use, but major services like, see, Azure Databricks, Azure Data Factory, Azure Data Lake Storage and 2, Azure Key Vault, Azure Logic Apps, Azure Synapse. These are all mandatory services you are going to use in any project. And in place of Synapse dedicated SQL pool, you may also use some external, okay, storage like Snowflake. We can go for external storage like Snowflake. Snowflake also we can use it. Clear? So fine, guys. And these are some, okay, dedicated, okay, services. Come on. And now when it comes to, okay, uh, guys, when it comes to, okay, distributed computing platform, when it comes to a distributed computing platform or distributed computing framework, yes, when it's a, just a minute, okay, and where is a distributed computing framework, written the points? Yeah, fine. Coming to distributed, okay, data processing paradigm or distributed computing framework. What are the most popular distributed computing frameworks? Most popular distributed computing frameworks. See, guys, and popular distributed computing frameworks. And distributed computing frameworks. Distributed computing frameworks. And what are the most popular distributed computing frameworks? Okay, sir, there are two guys. There are two popular distributed computing frameworks. There are two popular distributed computing frameworks. Okay, and one is one is known as Hadoop MapReducing model, and other one is Apache Spark, and the other one is Apache Spark, guys. So here, let us try to understand and how you guys can differentiate these big data processing frameworks. Okay, and let me write first point. The following are the big data processing frameworks, but the different architecture, speed, and use cases. Okay, but okay, but they differ. But they differ in architecture, and speed and use cases. Architecture and speed and use cases. Okay, sir, there are two popular big data processing frameworks, but these frameworks differ in architecture, speed, and use cases. And what are those popular framework names? Guys, could you please give me the what are the uh, big data processing framework names? Come on.
Hadoop,
One is Hadoop. So can you, one is a Hadoop, and second one is Apache Spark.
Spark.
Apache Spark. Guys, remember Hadoop. Hadoop is a big data processing framework, and Apache Spark is also big data processing framework, or distributed data processing paradigms. Okay, but these two big data processing framework that differ in architecture and speed and use cases. Okay, so first let us the very first framework, the first framework, big data processing framework introduced in 2005 is Apache Hadoop. Hadoop is the first distributed data processing framework. Distributed data processing framework, or big data processing framework. The very first framework. Okay, but it has some limitations, guys. It has some limitations, and to overcome the limitations, in 2008, a new framework, means advanced to the Hadoop, a new framework got introduced, is Apache Spark. Okay, so and Apache Spark can process the data with a lightning speed when comparing with the Hadoop. So when you compare these two frameworks, Apache Spark can process the data with a lightning speed when comparing with Hadoop. So you guys can raise a question, sir, in what way Apache Spark can process the data with a lightning speed when comparing with the Hadoop? So, and the first, guys, I want to write some important points on Hadoop side. I will explain the Hadoop part, okay, and after that I'll explain the Apache Spark, how it can process the data. That, sir, even Hadoop is also from Apache Software Foundation only. So even you can say Apache Hadoop. Clear. So let us say, guys, and first let me and talk about the Hadoop part. Okay. Say, I'm writing, guys, Hadoop. Okay, say here. Distributed computing framework, hyphen Hadoop. Yes, or big data processing framework. Any terminology you can use it. And the first one is, guys, remember, and first processing type, sir, and supports. Okay, supports only. Okay, batch processing. Supports batch processing only. Supports batch processing only. Otherwise, better write supports batch processing only. And guys, anybody can define what is a batch processing? The name itself saying, guys, batch processing only. Batch processing means, guys, processing the chunks or okay, chunks of data. Processing the chunks of data in a regular interval of time. Processing the chunks of data. Processing the chunks of data in a regular interval of time. That means regular interval of time means every 6 hours. Every 6 hours, collect the data in a batches. Every 6 hours, collect the data in batches and process and store. Or every 12 hours, collect the data, process in batches and store. Or every 24 hours. Yes. So guys, it suppose Hadoop supports only batch processing and process the data in batches, like in a regular interval of time, like every 6 hours or every 12 hours or every 24 hours. You are going to collect the data in batches. Data gets collected from the source systems in batches, and those batches will be processed. That's called only batch processing. Sir, there is another type of processing is called as, guys, real-time processing or streaming. What is the real-time processing or streaming means? Process the data as soon as it arrives at the source. Suppose, sir, now time is 7:22. Time is 7:22. And when 7:22, if the data is generated and within next few seconds or within few minutes, like 1 minute or 2 minutes, the data will be collected. Within the minute, within few seconds, the data will be collected, processed and stored. That is called real time data. Real time data or streaming data. And that kind of processing is also called as a real time analytics or streaming analytics. Okay, but unfortunately, guys, Hadoop does not support streaming. Hadoop does not support streaming. Yes, it does not have inbuilt capability for streaming process. Okay, whereas, guys, when it comes to the Apache Spark, when it comes to the Apache Spark, yes, and it supports both batch processing as well as real-time streaming or real-time processing on machine learning processing and graphics processing and all the different types of processing capabilities, and Apache Spark can have it. So parallelly, when you are comparing, okay, I will write even Apache Spark also parallelly, guys, here at the bottom. When it comes to Apache Spark, okay, so here first comparison, okay, I'll give you here, see, uh, processing type. Okay, first one, guys, processing type. When it comes to the Hadoop part, Hadoop processing type supports batch processing only. Yes, but when it comes to guys Apache Spark, okay, now same thing, processing type, okay, supports batch processing, guys, supports batch processing plus supports batch processing plus, okay, real time, okay, or in bracket I'm writing streaming, okay, streaming, okay, real time processing plus it supports machine learning and supports graphics processing, guys, supports graphics processing, okay, and supports graphics processing. And see, graphics is another type of process, okay, and see guys, supports, okay. Sir, these many, okay, the processings it supports. See guys, what are the different types of processing supports by Apache Spark? Sir, your Apache Spark supports batch processing, plus the most important one is real-time processing. Sir, when it comes to the processing type, and real-time processing, machine learning, and graph processing, all these types of processing supports. So when comparing processing type, yes, Hadoop supports only batch processing, whereas Apache Spark supports various types of processings, including and machine learning and graphics processing, including machine learning and graphics processing. Clear? So that's it. And the next one is, guys, remember, and okay, next, when it comes to speed, okay, when it comes to the second very important speed, performance speed is, okay, second comparison I'm giving, okay, speed. When it comes to the speed, guys, okay, when it comes to the speed in Hadoop, guys, Hadoop is slower, performance wise is slower. Why it's a slower? Okay, that is the only very important discussion you need to, okay, since, okay, okay, I'm writing, guys, since it uses since it uses disk based approach, since it uses a disk based approach, disk, as highlight it, disk, since it uses since it uses disk based approach, since it uses disk based approach, okay, approach, okay, it is, okay, slower, it is slower, okay, for each operation, for each operation, it is slower for each operation. So that's what more elaboration is required, guys, in this. What is disk based approach? Sir, hadoop uses disk based approach, okay, comma, as a result it is slower for each operation, comma, as a result, it is slower, it is slower for each operation, and slower for each operation. Clear? And so, and when it comes to, guys, okay, uh, Apache Spark, okay, I'll explain, sir, reason, I'll explain why it is slower, okay, with the diagrammatic explanation I will do. But here we'll write first, okay, comparison. Here also, when you compare with the speed, okay, much faster. See guys, I'm writing, and much faster, guys, much faster, and keeps the most data in memory, that's RAM, during computation. Okay, so I'm writing here, keeps most data, okay, in memory, keeps most data in memory. In memory means bracket I'm writing RAM. In memory, means RAM. In memory during computation. Computation means, guys, bracket you can write processing. Okay, that means, guys, it uses memory based approach. Okay, and in bracket much faster. Okay, because it most data kept in memory during, most faster and uses better, right? Most faster and uses, okay, and uses, okay, memory based approach. So let us highlight it, memory based approach, not disk based, guys, memory based approach. Okay, comma, and most data, okay, most data in memory during computation. Okay, so now when comparing with see processing type and speed. Okay, sir, and since Hadoop uses disk-based approach, it processing, okay, its processing speed is slower. Processing speed is slower when comparing with Apache Spark. Apache Spark uses memory-based approach, guys. It uses memory-based approach. Memory-based approach means, okay, in-memory computation. And when it comes to the storage, data storage part, okay, and see storage, and this is also very important when it comes to storage, okay, and Hadoop uses, okay, okay, HD HDFS. HDFS means, guys, uses HDFS means Hadoop, okay, distributed, okay, file system. HDFS uses HDFS to store data, okay, to store data. Whereas, guys, it uses only HDFS to store the data. But whereas when it comes to the Hadoop, when it comes to the Apache Spark and say storage, yes, sir, it can use HDFS or AWS S3 bucket, Azure Data Lake, or anything it uses storage. Okay, so here can use, okay, can use, okay, external, okay, storages can use external storages like AWS S3 bucket, comma, Azure Data Lake, comma, Azure Blob, okay, storage, comma, Google Cloud Storage, okay, and anything, guys. Even it can also use HDFS, Hadoop, okay, Hadoop distributed file system storage, okay, anything it can use it, okay. But whereas Hadoop can use only HDFS, but whereas when it comes to Apache Spark, can use any external storages, okay. And here, and one more thing, okay, yeah, when some point has come, okay. That's what here, and Amrish, remember, and what we written, And when it comes to much faster and uses memory based approach, most data, okay, in memory. Yes, if suppose if the data does not fit in the memory while processing, it spills the data to the disk. It spills the data to the disk if it does not fit memory. Okay, so according to that, what is the volume of data which you are processing, based on that you need to make your configurations. See, that's the reason I've written not all the data in RAM memory. Most data is going to be stored in the RAM memory, okay, while processing. And suppose if the RAM memory is not sufficient, then it spills the data to disk. But spilling the data to the disk, if the RAM memory does not enough, if the RAM memory is not enough to store, if it spills the data to the disk, then certainly it will have some impact on the performance. Are you clear, Amarish?
Yes, sir.
Yeah, that's the reason I've written most data. Yes, I have not written all the data in memory, most data. Okay, so anyway, and when it comes to, guys, one more, okay, a simple comparison, what kind of programming model? Okay, and here, and programming model, guys. Okay, fourth one. And guys, wait, I will explain what is a disk based and memory based. Certainly I will explain why, because after that only you will get the confidence why Apache Spark has become more popular for processing the big data when comparing with the Hadoop. If you want to know this point especially, and if you want to make sure that you are confident on this point, compulsory you should know what is disk based approach and what is a memory based approach. That, and within a few minutes, maximum within 5 minutes down the line, we'll go to the topic and I'll explain with the diagrammatic representation. Sir, when it comes to programming model, and see guys, a programming model, and if you want to process the data, what kind of programming model you are going to use, sir? And the programming model is called as a MapReduce programming model, or map and reduce programming model. See guys, map and reduce, okay, programming, okay, model. Okay, this called mappers and reduce. Okay, mappers, you are going to create the mappers. Okay, mappers and reducers are going to be, okay, created. Okay, that's called map and reduce programming model. And the language supports is, guys, one more thing, fifth point also, guys. Okay, and the language and used is, the language used for MapReduce programming model is Java. It uses Java. Yes, that's the reason, guys. It's a bit complex. Okay, and complex needs more coding. Okay, and see, programming language, programming language. Okay, supports Java only. Supports Java only, and okay, and more code need. Okay, needs more code and complex. Okay, see, programming language supports Java only, needs more code and complex. Okay, more complex to write the code. So, guys, this mapper program, reduce program. Okay, you need to create okay, map reduce programming model. To define map reduce programming model, you use Java, and Java is very complex and more code is required. But when it comes to Apache Spark, okay, so fourth one, programming model. Yes, what is a programming model here? What the programming model is required? Sir, here, okay, the programming model is, okay, and high level, okay, APIs. Guys, programming model is high level APIs will be used. That's called data frames and SQL. Okay, guys, programming model and uses high level APIs. Okay, APIs such as, okay, data frame, comma, RDD, comma, and SQL. Guys, SQL, RDDs, data frames. Okay, data frame, RDD. Sir, now you're all practicals in Databricks. We do it on data frame only. Very important one. Data frame programming. Okay, data frame API. I like that RDD API. RDD stands for Resilient Distributed Data Set and the SQL API. These are all different levels of APIs will be used for the programming model. But what are the languages? What are the languages supports? Okay, and see programming languages. What are the programming languages it supports? Okay, so guys, more when it comes to guys supports Python, Scala language, yes, and supports SQL and supports, okay, R language, yes, even it supports guys Java also it supports. Yes, it supports even R language, even Java also it supports guys. But sir, here and since Python is a high level, okay, programming language, and Python is one of the and easiest programming language to adopt and supports lot of libraries for data engineering, lot of data engineering libraries for computation, machine learning libraries for predictive modeling, lot of libraries. So and universally and most of the projects got implemented using Python language. Yes, even guys, you people are always saying, okay, PySpark. While learning Databricks, you are going to learn PySpark. What do you mean by PySpark? Here I'm writing, sir. See, and PySpark. PySpark is nothing but see, PySpark. What do you mean by PySpark? That's nothing but a guys. Okay, and understand, sir. Here, PySpark is nothing but guys, and see, Spark plus Python, or otherwise you guys can say first write Python plus Spark. Okay, see py means Python and Spark means what are the code you write in Python, the code gets process the data. What are the code you write in Python, that code is responsible to process the data on distributed computing engine called Spark, Apache Spark. Okay, so here and PySpark means write the code in Python, that code executes on Spark, okay, as an engine. Okay, so guys here and very important, okay, that's called PySpark. And okay, I hope you guys are very clear. And one more very interesting point guys on when it comes to the uh, Python, when it comes to the Python guys, okay, uh, here Apache Spark is a distributed computing engine only, or data processing engine only. Okay, and put a note, okay, here I will write as a, okay, and Apache Spark key point I'm writing, sir, Apache Spark about a key points. And when it comes to the key points, guys, Apache Spark key points. First one, okay. Apache Spark is a, okay. Apache Spark is a in-memory. Yes, Apache Spark is a in-memory distributed, okay, in-memory. Better write in bracket. In-memory, comma, distributed computing engine only. Guys, see, I'm writing, see, Apache Spark is a in-memory distributed computing engine only to process large volumes of data, to process massive volumes of data, to process massive volumes of data parallelly on, okay, multiple, okay, machines or nodes. So what is actually meaning of distributed computing engine only? Or otherwise, sir, same point you can also write like this. Okay, Apache Spark is a, okay, Apache Spark is a, okay, data is a data processing engine only, comma, it does not come up with, and physical storage media called, okay, disk. It does not come up with a physical storage media, a physical storage media called disk. Yes, means Apache Spark is a purely data processing engine. It's a computing engine. Okay, sir, computing means what, sir? Processing. Okay, compute means process. Okay, sir, compute means process, and only processing engine, and it does not comes with, okay, a physical storage media called disk. Hence, okay, continuation. Hence, okay, and Spark uses, hence Apache Spark uses, external, okay, storage media, external storages called, okay, AWS S3 bucket, yeah, anything S3 bucket, Azure Data Lake, etc. Hence, Apache Spark uses external storages for storing the, okay, for storing the data. Whatever the data is processed, to store the data, it uses some external storages. Why? Because Spark does not, okay, comes with inbuilt physical storage media. Apache Spark does not comes with inbuilt physical storage media called disk. It's a purely processing engine. It does not come up with a physical storage media called disk to store the data. Hence, your Apache Spark uses external storages. Okay, but whereas when it comes to Hadoop, guys, when it comes to Hadoop, and Hadoop comes with, okay, Hadoop comes with a distributed computing engine plus a physical storage media. Both will come. Both it comes. Okay. and both are tightly integrated. Processing engine and physical storage media are both tightly integrated. Tightly integrated. Tightly integrated, guys. Okay. So here, and see, guys, it supports in architecture wise. If you look it out, okay, architecture and 6 point I'm writing. See, architecture wise, okay, it's a and tightly coupled. Tightly coupled. Okay, architecture is tightly coupled. Tightly coupled means, guys, in bracket I'm writing tightly coupled means, okay, here compute. Compute means processing engine. Compute plus, okay, storage. Compute plus, okay, storage is tightly coupled. Tightly coupled, okay, tightly coupled means compute plus storage are tightly integrated in every node. Okay, and compute and storage are tightly integrated in every node. Okay, and if you want, okay, I can write one more point. Okay, both compute and storage are, okay, tightly coupled in every node. Sir, both compute and storage are tightly coupled in every node. In every node. Yes, but whereas, guys, here node contains only compute only. The node is only a compute. It does not have any storage in Apache Spark. Yes, when it comes to architecture, guys, here, sorry, this is written in Spark side. Sorry, this architecture, let us, you need to write in Hadoop side. Sorry. Okay, tightly coupled. Sir, on Hadoop part, it's a tightly coupled means compute and storage both are tightly coupled in every node. Okay, but whereas, guys, when it comes to Apache Spark, architecture, when it comes to architecture part, okay, both compute and storage are both compute and storage are loosely coupled. Loosely coupled. Okay, loosely coupled in the sense, guys, decoupled. Decoupled, guys. Decoupled. Loosely coupled means decoupled. Okay, both compute and storage. Okay, that's the reason the point has written Apache Spark is the only data processing engine. It does not contain any physical storage media called disk. And whatever the data processed by the Spark engine, if you want to store the data, you need to use some external storages. Okay, so diagrammatically, guys, if you look at the diagrammatically, and let us go for, okay, Microsoft Paint application. Just 1 minute. Sir, when it comes to Hadoop, guys, remember, suppose if you look at the diagram of, okay, and Hadoop architecture and simple representation I'm writing. So when it comes to Hadoop, guys, okay, and here compute, you have a compute. Compute is nothing but an engine to process the data. You have a compute to process the data, and this compute is tightly integrated, guys. This compute is tightly integrated. Okay, now let us So tightly integrated with, okay, here storage. Yes, that storage is HDFS. Sir, this is repeated in every node. Every node in the sense, same machine. Okay, node. Node is nothing but a, and like that in every node. If you have multiple nodes, in every node, you have a compute and storage. Both are tightly integrated in Hadoop. Yes, but whereas when it comes to, okay, Apache Spark, guys, observe when it comes to Apache Spark side. Suppose, sir, if you consider this as an Apache Spark. When it comes to Apache Spark is a only distributed computing engine in memory. In memory distributed computing engine. Only data processing engine. That means, guys, it contains only compute. It contains only compute. Okay, better 1 minute, sir. I'll erase the diagram once. 1 minute. Once again, draw the diagram. Okay, now here, okay, it contains only compute. Only compute. Okay, see here. A compute is nothing but a processing. Okay, Apache Spark comes with only compute. Now, this compute will process the data. This compute engine will process the data. Whatever the data is processed, okay, this is a node only. Again, this is a node. Node is nothing but a machine, computer, node. Yes, this is a node. Now see, this node contains only compute, only processing engine. Okay, and now what are the data processed by this node? The data somewhere we have to store it. For storing part, it depends on some external storages. Okay, again, sir, some external storages at the bottom. I'm writing some external storage. Okay, so guys, this is a storage. Storage. Okay, and here, and storage can be like anything where you're going to store the data, that processed data. See here, and processed data will be stored here. Okay, so guys, here, and you can make a link like, okay, see here. Okay. Now tell me, sir, when you look at these two diagrams, you tell me that, okay, which is tightly coupled, which is loosely coupled, which is tightly coupled, and which
Hadoop
is
is
tightly coupled architecture, whereas Apache Spark is comes under loosely coupled architecture. Yes, so, and which is independently scalable. Hadoop and Apache Spark, which is independently scalable, which is
Apache
dependent
Spark.
scalable. Yeah,
Apache
Apache
Hadoop
Spark
is
Spark will be
dependent.
independently scalable.
independently scalable. Apache Spark is independently scalable. Means independently scalable means a compute is scalable, compute power, compute is scalable without depending on storage, and storage is scalable without depending on compute. Yes. So these are the two independent layers. Compute is one layer, storage is another layer. Two independent layers. Each layer is scalable without depending on other. But whereas when it comes to the Hadoop, yes, when it comes to the Hadoop, okay, scalabilities depend on each other. It's not independent. The reason, sir, when the volume of data is increasing, when the volume of data increase in the node, then you should also increase the processing capacity also. Come on, compute capacity. Come on, yes. If the volume of data increases, you should also increase compute. Why? Because both are dedicated in a single machine. Clear? So if the storage is increased, compute should be increased. Okay. So guys, now tell me, sir, when comparing with these two diagrams, which is highly capable, which architecture is more capable of handling the big data processing? Come on.
Apache Spark will be.
Apache Spark. But still, sir, okay, some more discussion is required. And don't think that today is over. Even I should explain what is disk-based and memory-based, because this is very important. Certainly, this question comes in the interviews. Okay, the reason you can ask the question, sir, why this question comes in interviews means, sir, here you have written, okay, Azure services, you have written Azure Databricks. Okay, maybe, okay, now for the time being, I'm writing, okay, and make a question yourself. What is, for the time being, I'm telling, what is Azure Databricks? What is Azure Databricks? Okay, and then you guys can give the definition as Azure Databricks is a cloud-based data analytics platform. Sir, Azure Databricks is a cloud-based data analytics platform which is built on top of, okay, okay, um, Apache Spark. That's what the definition, which is built on top of Apache Spark. Now make a question yourself. What is Apache Spark? Apache Spark is nothing but about, sir, an in-memory distributed computing engine only to process massive volumes of data parallelly across multiple machines or nodes. Every node contains only compute. Every node contains only compute. Yes, every node contains only compute. Understand, guys? Every node contains only compute. Okay, so guys, please remember. Okay, and now okay, so finally your Databricks at the back end, your Databricks uses, Apache Spark to handle massive volumes of data to process more efficiently. Clear? So that's it. Okay, but guys, we'll continue tomorrow. Yes, we'll continue tomorrow this topic. I'll explain diagrammatically what is disk-based approach and what is a memory-based approach. And finally, according to the today's discussion, you tell me, as per the today's discussion, tell me which is more popular distributed computing framework when comparing Hadoop and Spark? Which
Apache
is more
Spark.
popular? Apache Spark. Apache Spark. Sir, architecture wise and programming wise, okay, and the speed wise and processing type wise, more efficient. Okay, and see, and even we use PySpark, means Python based Spark programming. Spark programming to process massive volumes of data. Very easy, sir. PySpark is very, very, very easy that, and it's not like a pure Python. Okay, it's not like a pure Python. Okay, and PySpark comes with some libraries. We have to use the libraries to process the massive volumes of data. So coding is very less coding, very comfortably you people can walk, but practice is very important. That's what I'm saying. Practice. If you have a practice, you guys can easily handle the things. Okay, but anyway, don't worry, I will make sure that you will be very strong in PySpark part. Okay, so, and Python based Spark programming to process the data on distributed computing engine that uses in-memory computing or in-memory processing that. But like Amaresh has raised the one question, what happens? Yes, sir, what is the question raised by Amaresh is, uh, how does the system handle the cases where data does not fit in memory? Very good. So here, guys, you are saying in-memory computing, but that means what? The total data needs to be processed in memory, in RAM memory. If unfortunately, if the RAM memory is not enough to fit, if the RAM memory is not enough to fit the large data, then, okay, certainly, and Spark uses disk spilling. Disk spill, that means how much data is possible to fit in the RAM memory, that will be processed, and the remaining data will be stored for a while in disk only. Okay, but that uses automatically, but it is not recommended. Why? Because again, disk spilling is involved. If the disk spill involved, it will have impact on the performance. That's the reason. Yes, you need to calculate how much memory configurations needs to be calculated, and as per that proceed. Suppose you can observe in processing log, any disk spills occurs, then you should intimate to your administrators. They will take care of, okay, how to increase the in memory part. Okay, so fine. Anyway, guys, and
Uh,
here I'm
Hello,
stopping.